Now in class 12th, I am telling you the last application of this potentiometer, that is the calibration of ammeter by potentiometer. So just like voltmeter, here we have the calibration of ammeter also. And one thing that may come in mind, that since the potentiometer measures the potential difference, then how will it measure the current? So for that purpose we are taking a standard resistance of 1 ohm. Then whatever the potential difference is across the 1 ohm resistance, that is equal to the current passing through the circuit. So similar questions are to be asked, that what is the calibration and why do we standardize to this one, and the electrical circuit, and finally working and the calibration curve. So any two questions, two parts in a single question may be set, or this may be the complete question of 4 marks or complete question of 3 marks also. So now let us take the calibration of ammeter by potentiometer. The calibration of ammeter. Means to check the correctness or accuracy of ammeter by potentiometer. The circuit diagram. Circuit diagram. The circuit diagram is like this. RH, this is now K, EMF E, it's EMF E naught, this is the galvanometer, this is Jogi J by AB, and that this is the 1 ohm resistance. And then here we have a ammeter. This is RH dash. This is now your K dash, and here the current is passed through this wire AB. Here we use 1 ohm standard resistance. This is the circuit diagram of potentiometer. This is the main circuit, and this is ammeter circuit. Ammeter circuit. So in ammeter circuit we are having the 1 ohm resistance, the ammeter which is to be calibrated. This is positive and negative. This is now your rheostat. This is now key, and then the cell. This is E0 is the standard cell of known EMF, constant EMF. The current from main circuit is allowed to pass through potentiometer by A. This is not two-way key, X, Y and Z. So first we connect X, Y so that this standard cell of known EMF is taken into the circuit. By connecting X by the standard cell of constant EMF E0 is taken in circuit. The jockey G is slided on the wire AB for getting null deflection in galvanometer. Let L not equal to balance length. Balance length. Balance length. Now this RH is so adjusted that L0 is maximum. The rheostat in main circuit is so adjusted that L0 is maximum. So now potential gradient is how much? Potential gradient X equal to E0 upon L0. Thus the standardization of the potentiometer is standardized. Thus potentiometer is standardized. Is standardized. So now then what we do that after standardizing this xy is disconnected and yz is disconnected, so that this 1 ohm resistance is in the circuit of potentiometer, or this is the main circuit. After disconnecting xy, yz is connected. The standard resistance of 1 ohm resistance of 1 ohm is taken in main circuit. Is taken in main circuit. Since potentiometer measures potential difference, potential difference, not the current. So 1 ohm resistance is taken the potential difference across 1 ohm resistance is equal to the current passing through the circuit. Through the circuit, and it will be the reading that we taken from by means of the potentiometer. So potential difference this is equal to I into R. This is now R is equal to 1 ohm. 1 ohm, so this is equal to what? I. So whatever potential difference we measure across the 1 ohm resistance, that will be equal to the current measured by the potentiometer. The potential difference difference across the one known resistance is equal to the current passing through the circuit. So this potential difference will be measured by the potentiometer. So potentiometer reading will be like this one. So let's this to be now your IDES. This is now IDES. It is the reading of potentiometer. Now what we have? For different values, different readings of ammeter, the corresponding valence length is obtained by sliding, जो कि J on the wire, on the wire A. So now let's let I equal to reading of ammeter and the potentiometer reading potentiometer reading IDES. This is equal to, this is what, this is not so much, this IDES. IDES equal to X into L, where L is the balancing length. So let L equal to balance length. So this we have E naught upon L naught into L. This is equal to IDES. Then the error delta I is equal to I minus IDES. Then we draw a calibration curve. Draw a calibration curve between delta I and I. So this will be like this one. This is x-axis, this is your y-axis, this is 0, this is now delta I on this side and on this side also, because delta I may be positive, negative or 0. So here we take the readings. Suppose this is now one reading, then to this one, this, and then to this. So thus we are getting a number of readings. Here we take the I. So from this calibration curve we can obtain the value of the potentiometer, and then you can just compare the values of I and I dash when this error is coming out to be less and very less, only then the instrument is okay. So this calibration curve gives you that how much is the error in the board ammeter readings. So for the purpose of the this instrument should be employed in the electrical circuit, the error must be as small as possible. So this is what about the calibration of the ammeter by potentiometer. So the question are asked in both the ways, that how to calibrate the ammeter, what is the meaning of calibration, how the standardization is done in case of ammeter, and also this why 1 ohm resistance is employed in the ammeter circuit. This is the answer that I have given you here, and then the calibration curve, and then just you find the errors. So the instrument is calibrated by means of the potentiometer in this way. So thank you very much.